When you're solving a system of equations with three variables, sometimes we call those three equations with three unknowns because we don't know x, we don't know y, we don't know z. So I actually wanted to talk about that for just a second. Let me get that picture on my phone again. So here we have this picture, and we want to talk about x, y, and z. Well, this would be your x-axis, this would be your z-axis, and this would be your y-axis. So if you're talking about the point, let's say the point 2, -3, -1. It would go 2 on x, -3 on y, and then it would come towards you. I know you can't see what my marker's doing, but it's coming towards you at -1. Now z, depending on which side of this 3D axis you're looking at, towards you could be negative or away from you could be negative. Just depends on which side you're standing on. So let's say this is 2, -3, and then -1 is towards you. So it would actually be a point out here in this space. Okay? So that's what we're looking for. We're looking for an ordered triplet that represents a point of intersection of these three planes. Alright? So let's see what we can do with this problem. The very first thing that I always do is just number them. Equation 1, equation 2, equation 3. After that, you want to make sure you look at all three equations at the same time. Figure out, based on what you're looking at, which variable would be the easiest to eliminate in all three equations. I notice here I have a 3, a -1, and a 5. Here I have a -2, a 3, and a -5. Here I have a 1, a -1, and a 2. It seems like x's may be the easiest to eliminate. So let's do that. You want to take two of your equations. Let's take equations 1 and 2. And it does not matter which two you choose. You just want to eliminate x. Okay, so let's do that. If we were to add these together as they are, x is already eliminate. -2y plus 3y is 1y. 3z minus 1z is a positive 2z, and 9 minus 6 is 3. We have now created another equation. That's equation number 4. So the next go around, you must use the equation you did not use the first time, but you could use either of the other two, and you want to make something eliminate. Well, it looks like if we multiply equation 2, this one, by a positive 2, then our x's would eliminate, right? So this is what I'm going to do. I'm going to use equations 2 and 3. 3 gets to stay like it is. But equation number 2, I'm actually going to multiply it by, I'm looking for a good color. I'm going to multiply equation 2 by the number 2. So what I'm going to do is multiply everything in this equation by 2. So I have -2x, positive 6y, -2z, and -12. All I did was multiply everything in this equation by 2. If I add these together, x's go away again. 6y minus 5y is 1y. -2z plus 5z is 3z. And -12 plus 17 is 5. I have created equation number 5. So this is what's important at this point. These two new equations that you created, they need to have the same variables in them. That's why you always want to eliminate the same variable in all three equations in these first two steps. So now we're going to take equations 4 and 5 and solve them like we did in 11.1, or in the last section. So we're going to have y plus 2z equals 3, y plus 3z equals 5. You can solve this any way you like. I'm just going to continue using elimination. So if I multiply this one by a -1, I have negative y minus 2z equals -3. Equation 5 gets to stay the same. This is 0. Negative 2z plus 3z is 1z. Negative 3 plus 5 is 2. We already know z. Now remember, we're looking for an ordered triplet. We need an x, a y, and a z. Well, right now we know z is 2. So let's continue. If we know z is 2, we can take it back up here to one of these. Either one will work. Let's plug it into the first one. So we have y plus 2 times 2 equals 3. Y plus 4 equals 3, which means y is -1. So now we know our y is -1. Now we know z and we know y. We can go back to the beginning. So we go back up here to the original and figure out which equation would help us solve for x. Now that we know these two, I'm going to go back to equation number 1. Remember, you can choose any equation you like. X is almost solved for in equation 1, which is why I chose that one. So we'll have x minus 2 times y plus 3 times z equals 9. Negative 2 times -1 is positive 2. 3 times 2 is 6. 2 plus 6 is 8. Subtract 8. And you find out that x is equal to 1. So we now have our ordered triplet. 1, -1, 2. These three planes will intersect at that point. Now to check your answer, you just plug 1 in for x, -1 in for y, 2 in for z, but you have to do that for every single equation and make sure that they create a true statement. So you should be able to check every one of your answers.